question, they were asked to find the 4-digit natural numbers such that all the digits are odd. To answer this question, we need to know how many odd digits are there. We have how many odd digits? That is 1, 3, 5, 7, 9. Totally, we have 5 odd digits, and they've asked 4-digit natural numbers such that all are odd. So each digit will have 5 possibilities. So 5 into 5 into 5 into 5. So totally we have 625 possibilities. So the answer is 625. In this question, they have asked about the value of R0 to N 2 power R C N comma R. To find the answer for this question, we need to assign the value for N. First, we have to take the value N equal to 1. If N is equal to 1, then the odd values will automatically, it will be 0 to 1. So first value, it will be N is equal to 1 and R is equal to 0. So if we substitute the values here, 2 power 0, C 1 comma 0. This value will be 2 power 0, 1 and C 1 0 is also 1. So 1 into 1, it is 1. And for N is equal to 1 and R is equal to 1, the value will be 2 power 1, C 1 1. So it will be 2 power 1 will be 2 into C 1 comma 1 will also be 1. So it is totally 2. So now the value will be for N is equal to 1, it is 1 plus 2. Totally it will be 3. So the answer will be in the form of 3 power N. In this question, they were asked to find different permutations of the word mathematics are listed as in the dictionary. How many words with or without meaning are there in the list before the first word that starts with C? So to find the answer for this question, we need to first write the word mathematics in the alphabetical order. So if we write the word as alphabetical order, that is A, C, E, H, I, M, T, S. So this is the mathematical order for the word mathematics. So first 2 words, that is AA, if we interchange, no variations will be there. So if we consider the other words with the 1A, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we have totally 10 factorial ways. And in this we have 2 repetitions, that is 2M and 2 T's are there. So these many permutations are there before the first word starts with C. So totally it will be 90720. So the answer is C. In this question, they have given 2 statements. First statement, they have given F is a subset of Z into Z. Z is integers, and they have given the function definition, that is x comma y into x minus y. Then x and y belongs to the integers. First, we will check the first statement, that is F is equal to x comma y, x minus y. So first we'll give some random values and we'll check the function. So first I'll take x equal to 3 and y is equal to 2. So if I take x equal to 3 and y is equal to 2, the function f will becomes 6 comma 3 minus 2, it is 1. And then if I give next set of values as x equal to 6 and y is equal to 1, now f will be 6 comma 6 minus 1, 5. So here in this, for both 6 will have 2 images, that is 1 and 5. For the function, each and every values of x, we should have only y, only 1 values. So here we have 2 images, which is not possible in the function. So it does not define the function. So the first statement is wrong. Then we'll check the second statement. If f is a subset of n into n, here n is natural numbers and they are given f is xy, comma x plus y. Here also it will give you same set of values. Here f will be 6 comma 3 plus 2, 5. And here, if I give the same x equal to 6 and y equal to 1, here the f will be 6 comma 6 plus 1, 7. Here also for 6, I'll get two values, that is 5 and then 7. Here also the function is not defined. So both the statements are wrong. So the correct statement is neither 1 nor 2. In this question, they have asked about what is the value of del, and they have given del value and they have given the value of elements of these, and then they have given the minus of these elements. Now we'll find the value of del with the formula del is equal to A13 into minor of A13 minus A23 minor of A23 plus A33 minor of A33. Now if you substitute the values, y is z minus y minus of zx z minus x plus xy y minus x. If you multiply inside, you will get y square z minus it is y z square minus y square z minus z square x plus zx square plus xy square minus x square y. And for my easy conversion, I have taken the x square in the front, x square into z minus y, and then I'll take in this form of z minus y, so it will be minus x into z square minus y square. Next, plus yz into z minus y. Now I'll take z minus y from all these three elements. Then I'll get x square minus xz. Here it will be split into z minus y, z plus y. So it will be minus xz minus xy plus yz. Now if I take x from commonly from this one, x minus z, and here if I take y commonly out, x minus z. Now I'll get the answer as x minus z, z minus y, and then x minus y. So the answer is option A. In this question, they have given the A matrix and they have given some statements about the A matrix. First statement is A plus Aj is a null matrix, and then second statement is A inverse plus Aj is a null matrix, and then third statement is A minus A inverse is a null matrix. So we have to find Aj and then A inverse. So before finding Aj and then A inverse, we need to find the determinant of A. So to find determinant of A, 1 into minus cos square theta minus sin square theta. You know the value of minus cos square theta minus sin square theta. If we take minus outside, it is cos square plus sin square. So it is minus 1. So 1 into minus 1, minus 1. So determinant value is minus 1. Now we have to find the Aj. So first, for finding the Aj, we'll have some technique. So we have to start with the second row, second element, that is cos theta, and then we'll move next element and then come back to first element and then come back under the cos theta. So like this, we have to form a 4 elements, that is cos theta, sin theta, and then 0, and then cos theta. Now next we have to go for the second row, that is sin theta minus cos theta, 0, sin theta. Sin theta minus cos theta 0 sin theta, and then in the first row 0 0 1 0, and then we'll end in the same cos theta sin theta 0 cos theta. If we cross multiply this, we'll get the RGA. So RGA is minus cos square theta minus sin square theta. So it will be minus 1, and then 0 0. So it is 0 here, and here also it is 0, and then here 0, and then here it is minus cos theta, and then minus sin theta, and then here it is 0, and then it is here minus sin theta, and then here plus cos theta. So this is your RGA. Now we'll see about the A inverse. What is A inverse value, ma? A inverse value is 1 by determinant of A into RGA. If we substitute the values, it will be 1, because minus 1 into minus 1, 1, 0, 0, 0, cos theta, sin theta, 0, sin theta, minus cos theta. This is same as determinant A. So now we have found out A inverse RGA. So now we'll see the first statement. What is the first statement? A plus RGA. If you add A plus RGA, that is 1 minus 1 0, the element also 0, the element also 0, then next 0, cos theta minus cos theta, sin theta minus sin theta, 0, sin theta minus sin theta, minus cos theta plus cos theta. So totally we'll get all elements are 0. So it is a null matrix 0. So first statement is correct. Now we'll go to the next statement, that is A inverse plus RJ. A inverse is nothing but A. So A plus RJ, it is first statement itself, it is proved as a null matrix. So it is 0. And the next statement, A minus A inverse. A inverse itself A. So A minus A, it is a null matrix. So the third statement is also a null matrix. So the all statements are true. So the answer is D. In this question, they have asked about the matrix multiplication. First one, we need to know the condition about the matrix multiplication. If we want to multiply two matrices, it is, for example, P with the order of A cross B and Q with the order of C cross D. If I want to multiply P and Q, then it should be satisfied that B is equal to C. If B equal to C, we can multiply the two matrices P and Q, and the resultant matrix or will be in the form of A cross D. So such that we need to check the conditions of these every matrix multiplication. Okay, so first one we'll see about the ZY into X. First one is that they have given us 3 cross 2 matrix. So it's Z 3 cross 2 and then Y as 2 cross 3. So the certain matrix will be in the form of 3 cross 3, and this will be multiplied with X as 3 cross 3. So the resultant matrix will be in the form of 3 cross 3 matrix, that is will have 9 elements. So the first statement is true. And we'll go to the next statement. The matrix multiplication will be Y X Z. Here the X as 3 cross 3 and Z as 3 cross 2. So the resultant matrix will be in the form of 3 cross 2, and this will be multiplied with Y. That is 2 cross 3. So the resultant matrix will be form of 2 cross 2. This 4 entries, 4 elements. So second statement is also true, and we'll check the third statement. Y Z. Y as 2 into 3 and Z as 3 into 2. So the resultant will be 2 cross 2. and this will be multiplied with x as 3 cross 3. Here 3 and 2 is not equal, so we can't multiply these two matrices, so it is not defined. So the third statement is also correct. So all the three statements are correct. In this question, they asked for how many quadratic equations the sum of the roots is equal to the product of the roots. We know the formula, that is sum of the roots is equal to minus b by a. The product of the roots is equal to c by a if the equation is in the form of ax square plus bx plus c. So in the question they have given that sum of the roots is equal to product of the roots. So these two equations are equal. So it is minus b by a equal to c by a. Now if I multiply both sides by a, it become minus b equal to c. Then it will be b plus c is equal to 0. So we have to check for what values the b plus c is equal to 0. So if we substitute 1, that is b equal to 1, then we have to take c is equal to minus 1. And if we substitute b is equal to 2, and c we can take it as minus 2. So like that we can substitute n number of values. So the answer is infinitely many solutions. In this question, they have given about two statements. We need to find which one is correct. We'll see the first statement, the set of all irrational numbers between root 2 and root 5. We know that the set of irrational numbers between two irrational numbers is always an infinite set. So the first statement is true. Then we'll see the second statement, the set of all odd integers less than 100 is a finite set. They have given odd integers. So the odd integers will have negative integers and positive integers, and they have given less than 100. They have given only said about the positive set, that is till 99. They didn't say about the negative integers. The negative integers, it will goes to minus infinity. No, so it is not a finite set. So the second statement is wrong. So the answer is statement 1 only correct. In this question also it is a statement sum. The first statement is 2 plus 4 plus 6 plus till 2n is equal to n square plus n. So the first statement is nothing but sum of even numbers till 2n. Direct formula it is n square plus n. So the first statement is correct. We'll see the second statement. The expression n square plus n plus 41 is always gives a prime number for every natural number n. They have given for any natural number n square plus n plus 41 is always prime number they have given. First we'll see whether it is a prime number or not. If I substitute n equal to 40, we'll see what the expression will brings out. If n is equal to 40, it will become 40 square plus 40 plus 41. I take 40 from these two. If I take 40, it is 40 plus 1 plus 41. So now it is 40 into 41 plus 41. Now if I take 41 from these two expressions, now this will become 40 plus 1. That is 41 into 41. So this whole expression will be what? 41 square. So it is not a prime number because 41 is a factor for this number. So it is not a prime number for the natural number. N is equal to 40. So we can't tell this n square plus n plus 41 is a prime number. The statement is wrong. So the answer is statement 1 only correct.
Now we're going to see the 11th question, which is let P and Q, and the condition is P greater than Q, be the roots of the quadratic equation x square plus bx plus c equals 0, where c should be always greater than 0. And if P square plus Q square minus 11PQ equals 0, then what is P minus Q equal to? This is a very simple problem. It requires a little insight into the quadratic equations. Now, we all know that P square plus Q square can be written as P minus Q the whole square plus 2PQ. The minus 2PQ inside this and this will get cancelled. So we'll be left with the LHS. Now we can replace this in the original equation, which will become P minus Q the whole square plus 2PQ minus 11PQ equal to 0. So now we need P minus Q. So obviously we have to take everything else to the right hand side. Now P minus Q square will be equal to 9 PQ. P minus Q is equal to square root of 9 PQ, which is 3 into root of PQ. And since P and Q are the roots of the quadratic equation, PQ is the product of the roots of the quadratic equation, which is C by A. And in this case, A is 1. So the product of the quadratic equation product of the roots of the quadratic equation will become just C. So your answer will be 3 into root of C. Now we're going to see the 12th question. What is the diameter of a circle inscribed on a regular polygon of 12 sides, each of length 1 centimeter? So this is 1 centimeter. We have a 12-sided polygon. The inscribed circle will be like this. Instead of drawing the whole circle, you can have just the arc, which will give us the idea. So from the midpoint of this line, this side, draw line segment joining the center. This center will also be the center of the circle and also the center of the polygon. Now I'll join the vertex to this center. This is R. This is, if the whole side is 1 centimeter, then this side, this alone becomes half. Now we have a right angled triangle. We need to find R. If we know this angle, then we can use trigonometry to find R. If we know R, if we know the radius, we can find the diameter. So how to find this angle? In geometry, sum of the exterior angles of a polygon should equal to 360 degrees. So there are 12 sides. So each angle will be 360 divided by 12, which is equal to 30 degrees. So the whole angle is 180 degree. So your interior angle will be 180 minus 30, which is 150 degrees. So this line will bisect that angle. So this angle is 75 degrees. So tan 75 degrees is R by 1 by 2 is 2R. So this is our diameter. So the value of tan 75 is the answer. Where the value of tan 75 is 2 plus root 3, and this is our answer. Now we're going to see the 13th question. So let A be a set which has the elements 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. There's a function defined that the function should be the highest prime factor of x. For example, for 7 is the highest prime factor. For 8, it's 2 into 2 into 2. So 2 is the highest prime factor. For 9, it's 3 into 3. So 3 is highest prime factor. So this is the function. So what will be the range? How many elements are in the range of this function? So this is a very simple problem. We just need to write the function for everything. And then, for example, function of 7. This is 7. Function of 8. What is the highest prime factor of 8? That is 2. Highest prime factor of 9 is 3. Highest prime factor of 10. So 10 can be written as 2 into 5. So both are prime numbers, 2 into 5. So obviously the function of 10 will be 5. The function is finding the highest prime factor. That should be kept in mind. F of 11. 11 itself is a prime number. So highest prime factor is 11. So F of 12. 2 into 2 into 3. So 2 into 2, 4, 4 into 3, 12. The highest prime factor is 3. And then function of 13. 13 itself is a prime, so you have a 13. Function of 14. 7 into 2. 7 into 2 is 14. So 7 is your highest prime factor for 14. For 15 is 3 into 5. So 5 is the highest prime factor for 15. For 16 is 2 into 2 into 2 into 2. The highest prime factor is just 2. So I'll write the function. I'll write the range, the set of range. So you have 2, you have 3, you have 5, you have 7, you have 11, and then we have 13. There are 6 elements. So our answer is option C. Now we're going to see the 14th question. That's a relation defined from natural numbers to natural numbers. The relation is x comma y. X square should be equal to y cube. We should check whether the condition 1, 2, and 3 are correct. So the actual question is which of the following are not correct. So after checking, we'll see which of the following are not correct. So to check the first, see, this doesn't involve any values because this can be done just using the variables. For example, we have x comma x, right? If this belongs to the relation, then this should be true. X square equal to x cube should be true because if x comma y is equal to x, if x comma y relation corresponds to x square equal to y cube, then x comma x should correspond to x square equal to x cube. This is only true if x is 0 or 1. Sorry, 0 and 1. Okay, but not for any other natural numbers. Okay, this relation should satisfy all the natural numbers, but only 0 and 1 are satisfied, and also 0 is not a natural number. So 0 is a whole number. So 1 satisfies this equation, but not all natural numbers satisfy the equation. So 1 is not true. To check the second question, so if x comma y belongs to the relation, y comma x should also belong to the relation. So which means that you'll have x square equal to y cube and y square equal to x cube. We have both, and then this is the corresponding relation to both of these. Now, if both of this should be true, both of these should be true, then obviously only 0 and 1, only 0 and 1 holds true for both relations. If these two should be true, the value of x and y should be 0 and 1, but not all natural numbers. This can be ruled out also. Regarding the third relation, even by looking at it, I can say that this is not true. But let me show the proof. So obviously x comma y belongs to the relation. So x square equal to y cube, and then y comma z belongs to the relation. So y square equal to x z cube. Now they are telling you to check if x comma z belongs to the relation. So that would be x square equal to z cube. Since z cube is on the right hand side of both these equations, we can write x square equal to y square. Again, there's a contradiction that only holds true for 0 and 1, not all natural numbers. So 3 is also false. So the answer is option D, 1, 2, and 3. All of these options are false. Now we are going to see the question number 16. There is a complex number 1 plus I sin theta divided by 1 minus I sin theta. So you guys know that where I equal to root of negative 1. So that is its definition. So what is the modulus of z? This is a very straightforward question. To find the modulus of z, right? So z equal to, I'll write it like this because there are two complex numbers. Not two complex terms, actually this is one complex term, but is given in the form of z1 by z2. Of course, modulus of z is equal to, this can be written as like this. So without any hassle, we can just take the modulus of the numerator and take the modulus of the denominator, divide them both. So what is the numerator? So what is the modulus of 1 plus I sin theta? Of course, this is root of 1 plus sin square theta. This is of course z1, modulus of z1. So modulus of z2 is again 1 minus I sin theta. So this would be 1 plus sin square theta. So if you divide them both, you get 1. So the modulus is 1. Now we're going to see the 17th question. The same direction for the 16th question applies to this. You have a complex number 1 plus I sin theta divided by 1 minus I sin theta. We have to find theta. That is, there's a theta in the sin theta, right? We have to find that theta if that is purely real. Fine. So how to find this? First, z equal to 1 plus I sin theta divided by 1 minus I sin theta. Take the conjugate. So you'll have 1 plus I sin theta and 1 plus I sin theta. You get, of course, 1 plus I sin theta the whole square, which is 1 minus sin square theta plus 2I sin theta divided by, this becomes 1 plus sin square theta. This is actually cos square theta, this value. So I'll write it as cos square theta plus 2I sin theta divided by 1 plus sin square theta. So if this is purely real, then its complex term should be equal to 0. That is 2I sin theta divided by 1 plus sin square theta. So this is your complex term. If this should be equal to 0, then the numerator should be equal to 0. The numerator is 2I sin theta. 2I sin theta should be equal to 0. So sin theta should be equal to 0. So obviously you get sin theta is equal to 0. Right. If sin theta should be equal to 0, then the values of this should be 0, 180, again 360. So this is n pi. The option C is your answer. Now we're going to see the 18th question. Obviously, we have found the value of z, that is without any imaginary number in the denominator. We have found the value in the previous question. So I have written it there. So what is the angle theta such that z is purely imaginary? So we'll make the real value 0. So we'll make this 0. So obviously making the numerator 0, you'll get cos square theta equal to 0, which means that cos theta equal to 0. So what are the values? Cos theta will be equal to 0. You get 90, you get 270, right? So it goes on like this. So the general term for this is 2n plus 1 pi by 2. So this is your answer. Right, so option B is our answer. Now we are going to see the 19th question. There is a direction. Let us let P be the sum of n positive numbers of an increasing arithmetic progression A, and then let Q be the sum of first n positive terms of another increasing arithmetic progression B. So let P and Q, the ratio of P to Q, that is 5n plus 4 to 9n plus 6. So what is the ratio of the first term of A to that of B? Actually, if we find the first term and then the common difference from this given data, then we can easily solve the coming 3 questions. So how to find that? So just P by Q. This is going to be equal to 5n plus 4 divided by 9n plus 6. The sum of an AP, the formula is n by 2, 2a plus n minus 1 d. Okay, so we have to change this into this. Of course, that is n by 2. Okay, I'll write it as like this: 2a2 plus n minus 1. This is d1 and then d2. So we have to convert this into this. So this n by 2 and n by 2 are the same, right? Only the value of a and d will change. So we can omit this. Okay, of course this should be there, but since it is in the numerator and the denominator, we can cancel, and then we should try to change this in the form of this. So we'll go about that. So you should have n minus 1d, right? So you have 5n. So if you should have n minus 1, so let's introduce minus 5 and plus 5 to the numerator. You will in a minute you will see why we're doing that. So minus 5 plus 5 plus 4. Nothing is changed. Nothing has changed because minus 5 and plus 5, this will get cancelled. And you have the previous term. So here you have 9. Introduce minus 9 and plus 9. Minus 9 plus 9 plus 6. This should get changed into, take the 5 common and take the 9 common. So 5 into n minus 1 plus 9 divided by 9 into n minus 1 plus 9 plus 6, 15. So we have got it. So we aimed for this. We aimed to get this and we got it. Right. So your 2a1 will be 9, your 2a2 will be 15, your d1 will be 5, your d2 will be 9. Of course, there is an n by 2 term, right? Of course, there is an n by 2 term in the numerator and the denominator, but that will get cancelled. So we can equate this. So from this, we can easily understand that for P, for A, the value of the first term is, 9 and the value of D is 5. For B, for the progression B, I write in capital letters, this is 15 and your D will be 9. So with this, we can solve for 19, 20 and 21 because these 3 questions have the same directions. So what is the ratio of the first term of the A to the first term of B? So we can apply just 1, right? So the first term of the A, the A is 9 by 2 and this is 15 by 2. Okay, because 2 into A1 is 9. So the A is 9 by 2 and then your capital will be 15 by 2. So first term of the A to the first term of the B. Your first term of the A is 9 by 2. Your first term of B is 15 by 2. Right. 9 by 2 divided by 15 by 2. So of course, 9 by 15. This is 3 by 5. Your D is the answer. See, this is the first term. We have found this to be the first terms. A and A. So the ratio is simply clear. 9 by 15, 3 by 5. 3 by 5 is your answer. Option D. Now we're going to see the 20th question. So what is the ratio of the 10th term? Is the direction for the previous question applies to this also. So the reason I urged you to find the values of the first term and the common difference for both the progressions so that we can solve this sum very easily. So finding these values means that we are solving all the three sums at the same time. Listen, so 10th term, we know the A values. So 9 by 2 plus 9 into, so n minus 1 d, that is 9 into 5, right? So divided by 15 by 2 plus 9 into 9. So the value is 9 by 2 plus 45 divided by 15 by 2 plus 81. The numerator is actually, we can take the LCM. Of course, there is 2 in the numerator and the denominator. So if you take the LCM, you get 9 plus 90 divided by 2 and then 15 plus 162 divided by 2. The 2 and 2 will get cancelled. So you're left with 9 plus 90 in the numerator, that is 99 divided by 15 plus 162. So 15 plus 162. The value is 771, that is 177. So this is our ratio. This can further be divided by 3. Right. So 3 means 5 3s are 15 and then 2 27. So 59. And then in the numerator we have 33. 33 by 59 is the answer. Option C is your answer. Now we're going to see the 21st question. Which of the following is always true? The reason I told you to find the capital A, D, capital B values of that. Now we know the values of D, which was 9, and then we know the the value of small d is 5. So obviously D is greater than small d, capital D is greater than small d. This is the answer. This is the reason that finding the required values is important. So this took no time at all. So the answer is option A.
In this question, they have given the statement that is binomial expansion of p plus q x whole to the power 9. In this, we will have following 3 questions. We'll see the first question. What is the value of q if the coefficient of x cube and x6 are equal? First, we need to know the particular term value for this question, that is TR plus 1. TR plus 1 is given by NCR a to the power n minus r b to the power r. So here we know that a equal to p and b is equal to qx. If we substitute here, TR plus 1 equal to NCR p n minus r qx to the power r. Here they have given coefficient of x cube and x to the power 6 are equal, means what the r value will be. For x cube, the r value will be 3. Then for x to the power 6, the r value will be 6. So T4 and T7 we have to find out. For T4, it is the coefficient of T4 is equal to the coefficient of T7. So the coefficient of T4 is NC3 p to the power 9 minus 3, 6, and q power 3 x cube equal to, here it is 9c 6 p to the power 3 q to the power 6 and x to the power 6. Here the coefficients are equal, means the value will be 9c3 p6 q3 is equal to 9c6 p3 q6. Here we know that 9c3 and 9c6 are equal. If 3 plus 6 is equal to 9, so the remaining elements will be P6 Q3 is equal to P3 Q6. Now, if we cross multiply, P cube equal to Q cube. So automatically P is equal to Q. So the value of Q will be P. The answer is A. This question also follows the binomial expansion of P plus Qx whole to the power 9. In this question, there was the ratio of the coefficients of middle terms in the expansion. First, we need to know the number of terms. If we have the power n, then the total number of terms will be n plus 1. Here we have 9 terms, the total number of terms will be 10. So the middle terms will be T5 and T6. They have given the ratio of the coefficient of middle terms. Then we need to find T5 by T6. So if we apply the TR plus 1 terms, that is NCR, P, R, Q, X, N minus R formula, then T5 by T6 will become 9C 4 P power 5 Q power 4 divided by 9C5 P power 4 Q power 5. We know that 9C4 and 9C5 are equal, because if we add 4 plus 5 will get 9. So both are equal. So obviously the remaining part will be P by Q. So the answer is B, P by Q. This question also follows the binomial expansion of P plus Qx whole to the power 9. In this question, they have given under what condition the coefficients of x square and x to the power 4 are equal. They have given such that x square and x to the power 4 are equal, under which condition they are asking. For that, first we need to know the formula of TR plus 1. Here it is 9CR P 9 minus R Q X to the power R. In the question, they have given the coefficients of x square and coefficients of x to the power 4. That is T3 and coefficients of T5 are equal. So first we'll list the coefficient of T3 and T4. So it is 9C 2 P to the power 9 minus 2 7 Q2. This will be equal to 9C4 P to the power of 9 minus 4 5 and Q to the power 4. Here 9C2 will be listed as 9 factorial divided by 9 minus 2 7 factorial 2 factorial. Then we'll take P one side. So P to the power 7 divided by P to the power 5. Here it will be 9 factorial divided by 9 minus 4 4 factorial and 5 factorial. So here it is Q power 4 divided by Q square. So here we get 9 into 8 divided by 1 into 2 P square. And here it is 9 into 8 into 7 into 6 divided by 1 into 2 into 3 into 4 Q square. Then here it is 2, 2. So P square by Q square will be 7 by 2. So the answer is P square is to Q square is 7 is to 2. Answer is B. In this question, they have given the word question. Based upon this, they have asked for 3 questions following from that. First question is, how many 4-letter words, each of 2 vowels and 2 consonants can be formed? So they are asking to find 4-letter word from this question with 2 vowels and 2 consonants. First, we have to specify which are the how many vowels are there and how many consonants are there. First, we'll see how many vowels are there. So the vowels are U, E, I, O, and the consonants are Q, S, T, N. So we have 4 vowels and 4 consonants are there. From this, we need to find 4 letters word. So we have 4 places. For these 4 places, we need to select 2 vowels. So for that, we need to take as 4C2. And for consonants, we need to take from these 4. That is Q, S, T, E, N. We need to select 2. So from U, E, I, O, U, we have to select 2. And from Q, S, T, N, we have to select 2. So from these 4 letters, they can arrange themselves among 4 factorial ways. So the answer is 4C2 into 4C2 into 4 factorial. So answer is 864. This question also follows the word question. Here they have asked, later words with or without meaning can be formed such that vowels and consonants occupy alternate positions. In the question, they have told that first vowel, consonant, and then vowel, consonant, like that, alternate positions we need to form with 8 letters word. So it is actually 8-letter word question itself. So they have told to find alternate positions. So we have that is vowel, consonant, vowel, consonant, vowel, consonant, vowel, consonant, one type, and then consonant, vowel, consonant, vowel, consonant, vowel, consonant, vowel. So like this, we'll have 2 variations. In these 2 variations, 1, 2, 3, 4 places vowels occupy. So it is 4 factorial ways. And same wise, consonants also can occupy in 4 factorial ways. So it is into 4 factorial. Here also 4 factorial into 4 factorial. So total number of words can be formed as 4 factorial ways into 4 factorial into 2 for these 2 variations. So totally it is 24 into 24 into 2. It is 1152. Answer is 1152. This is the last question with the word question. So here they have asked how many 8 letters words with or without meaning can be formed so that all consonants are together. So to answer this question, we need to first know how many consonants are there in this word question. The number of consonants are Q, S, T, N. So totally 4 consonants we have. So we can take these 4 consonants as a single word and the remaining vowels, that is U, E, I, O. So these letters are separately. So it is totally 1, 2, 3, 4, 5. So the words can be arranged in 5 factorial ways, and these 4 consonants can arrange themselves along in 4 factorial ways. So totally 5 factorial into 4 factorial, that is 120 into 24. So the answer is 2880. Answer B. This is question with the matrix A, and they have given C11, C12, C13 be the cofactors of A11, A12, A13. And they first question what they have asked is A11, the element A11 into cofactor 11 plus A12 into cofactor 12 plus A13 cofactor 13. We know that what is this one? This is the formula for del, correct? So the formula for del is what we have actually known as del is equal to A11 into cofactor 11 plus A12 into cofactor 12 plus A13 cofactor 13. This is what they have given in the question. So it is a direct question. So the answer is C. This question comes from the matrix A and the cofactors of A11, A12, A13 is C11, C12, C13. Now we'll see what is the given value, that is A21, C11, that is cofactor 11 plus A22, C12 plus A23, C13. We have to find it out. Okay, so I'll expand this one in this page. So we'll see what is A21. So for the central element, the sign should be, it should be in the negative sign, here plus sign, and then here minus sign, it should be there for the cofactors. So minus A21 into cofactor of C11 is A22 A33 minus A32 A23. Next plus A22 into C12 is A21 A33 minus A31 A23. Next one minus A23 into C13. It is cofactor 13 is A21 A32 minus A31 A22. Now if we expand this one, minus A21 A22 A33 plus A21 A32 A23 and then plus A22 A21 A33 minus A22 A31 A23 and minus A23 A21 A32 plus A23 A31 A22. Now we'll see, here we have minus A21 A22 A33 and here it is plus A22 A21 A33. So we can cancel this one out and here it is A21 A32 A23. Here plus here it is plus A21 A32 and A23. So this will be cancelled and the remaining A22 A31 A23. So this is also cancelled. So the remaining part is 0. So the answer is 0 here. This question also comes with the matrix A. Here they have given a determinant and they have asked to find the value of this determinant. I'll consider this value determinant as del 1. Okay, if I interchange a row or column, then the sign of this determinant will be changed. This is the property of this property of a determinant. So with this property, we can proceed with the question. Now I'll interchange the column 1 with column 3. Okay, so after the interchange, they will become A1, A13, A12, A31, A33, A32 and A21, A23, A22. Now I'll interchange column 2 with column 3. Now this will become A11, A13, A12 and A21, A23, A22, A31, A33, A32. Here after this change, one single change, this determinant value will become minus del 1. And here after this change, this minus sign will get plus sign because sign change will be there. So it will become plus del 1. Now after this one, here I think if I correct this row and column, I'll get somewhat equal values. So I'll interchange the row 2 with row 3. Okay. Now here it be A11, A21, A31 and then A12, A22, A32, A13, A23, A33. Now this determinant value will become minus del 1. Now see this matrix and our given A matrix. Both are same, only the transpose it will have. If we interchange transpose also, we'll get the same value in the determinant value. So nothing changed when we take the transpose. If I take transpose, the determinant value will be same. So it is minus del 1 equal to del. So the value of this determinant is equal to del 1 is equal to minus del. So the answer is D.